Okay guys, I just wanted to chew on one of these problems involving an actual situation that we could apply division to. And so taking a look at 52, we'll start with part A and then talk about how that connects to part B here. So but part A says here, would you do me a favor? Would you use synthetic division to show that 2 is a solution of this equation? And so again, let's go ahead and start with this. Instead of x's and y's, it looks like we have some h value here. But this equation, you'll notice that this whole equation is some a function of h, but it's set equal to 0. And so to show that 2 is a solution of this equation, we think that 2 is a solution of this equation, we want to go show that when we plug 2 into this function right here, we actually get 0 for a y value. And so the way we're going to do this is, well, I suppose we could use synthetic division. We have 2h to the third, 14h to the second, 0 x to the first, okay, h to the first, beg your pardon, and then negative 72. So if 2 is genuinely a solution of this, h equals 2, then what's going to happen when we do our synthetic division here is that we're going to find out that this last value right here, which would be h of 2, actually comes out to be 0, like we want to get for our equation here. So taking a look at this, we have 2 times 2, 4. 4 plus 14 is 18. 2 times 18 is 36. 0 plus 36 is just 36. But 2 times 36 is a positive 72, which gives us a 0 here. And so what we get is this 0 remainder. I suppose we get left with this quotient right here. 2h squared plus 18h plus 36 would be our quotient. But essentially, we were able to prove that h equals 2 is a solution of this because when we plug h or 2 into the equation, we get 0 for our y value there. So let's go ahead and take a look at this. We say h equals 2 is a solution to the equation because when we substitute h equals 2, we get 0. And so we can see that that's what we wanted to get up here, the h values that cause this whole thing to come out to be 0 there. So taking a look at this, part B says use the solution from part A to solve this problem. And so what we see here is that the width of a rectangular box is twice its height and the length is 7 inches more than the height. And so in either case we're saying the width is being compared to the height and the length is being compared to the height. And so looking at our box here, we can see that it looks like our height, which is this h right here, we can see that the width is 2 times as long as the h here. And it looks like that when we compare the length of the box here, we can say that that length right there is really the height, but plus 7 more inches than what the height is. And so we've already been given these 3 expressions here. Let me go ahead and put this third dimension going this way. But these 3 dimensions right here, what we want to do is we want to say that if the volume is actually 72 cubic inches, then we want to actually go find out, well, then what would cause h to make that happen, where, you know, the width is 2 times the height, and, you know, the length is 7 more than the height, and 72 cubic inches is our volume here, then what must h be? So we're going to start with this. The volume, okay, of a right rectangular prism in the first place is just the length times the width times the height. It's kind of boring, you guys. But what I want to do is I want to express this. We would say that the volume then in this case is our length. I noticed that our length is h plus 7. Our width here, well, that was 2h. And then our height, well, that's just h. And so what I want to do is I want to come up with a polynomial function that represents the volume here. I'm going to start by multiplying these out. I'll take 2h times h first. So we get h plus 7 times 2h squared. And as I distribute this, what I end up with is the volume is equal to 2h squared times h, which is 2h cubed, and then 2h squared times 7, which is 14h squared. Now this right here, this represents the volume of this right rectangular prism. But what I want you to see is that we were already given the volume and we were told that it was 72 cubic inches. So to look at it this way, what we could really do is we say, well, I want to know what is the h value that causes our volume to be 72. To solve this equation, of course we would set this equal to what? What do you want to set it equal to? Oh, obviously 0. We always, when we solve polynomial equations, we set it equal to 0 first. So what I'm going to do is I'm actually going to carry this 72 back over to the right-hand side to get a 0 on one side. And what I end up with is 2h cubed plus 14h squared. minus 72. And so the neat thing about this is, well, that was kind of what we had up here in this first part. And so in terms of, well, can we find any h values that cause this to be true? Well, we already found one h value up here that was a solution. And so in order to find the dimensions of the box, I suppose we would say that, well, h equals 2 is a solution to this equation. And so the neat thing here is a solution to this equation right here, the one we set equal to 0. So since it is a solution, then we could say, well, in the height really is 2, well, I suppose it'd be inches. So let's go ahead and list these out here. We say the height is equal to 2 inches. Now when we look at the width, we would say that the width here, the width which is really 2 times the height, was really 2 times 2 inches, then this would come out to be 4 inches. Okay. And then as far as the length is concerned, we said the length was really expressed in terms of the height as h plus 7, but because h is 2, we could say this is really 2 plus 7. Whoops, not really sure I put a parenthesis there. 2 plus 7, and we would get 9 inches. And so the dimensions of this box really are 2 inches by 4 inches by 9 inches. And hey, you know, it'd be really easy for us to just grab a calculator here and to prove that 2 times 4 times 9 does indeed give us a box that has 72 cubic inches as its volume. Cheers.